Hi everybody, welcome to Chapter 6 review, homework number 51. And Chapter 6 is about proportions and polygons, and here are some keys to success on the final. Know what it means for two polygons to be similar, okay, and we'll go over that. Know what a proportion is and how to solve it. And in order to do this, you need to know how to cross multiply. And we've done quite a bit of that on your homeworks and in class, so it shouldn't be a problem, but we will go over it in this video. So two polygons are similar, okay, if corresponding angles are congruent and corresponding side lengths are proportional. Okay, so the angles are congruent, meaning that they're equal to each other, and the corresponding side lengths are proportional. Proportional means that the ratios of the side lengths are the same. Of the side lengths. So if I have two polygons, I'll make it easy on, just draw two triangles. Now they obviously are not congruent. They don't equal each other, okay? But they can be similar. And they can be similar if this angle is congruent to this angle. This angle is congruent to this angle. Pick a color. And this angle is congruent to this angle. Know that these are both oriented the same way. Their longest way is vertically oriented, okay? And so you can easily identify the corresponding angles. So, but that's only half the battle. So the other part of it is that the corresponding side lengths are proportional. So that means this side length has to not be equal, but it has to be proportional to this side length. So I'm going to put that, and I'm going to write a wavy line, okay? And then this side length has to be proportional to this side length. And finally, this side length has to be proportional to this side length. Now, what does proportional mean? Proportional means that the ratios of the side lengths are the same. So, if this were, for instance, 3, 4, 5, and this, to look at the side lengths of this triangle, each of these numbers in the smaller triangle would have to be multiplied by the same number. So their proportions would be the same. So let's multiply each of these numbers, say, by 2. So 2 times 3 is 6, 2 times 5 is 10, 2 times 4 is 8. So what are the proportions? So in the blue, we have 3 over 6. Okay. In the yellow, we have 5 over 10. Okay, and these are ratios, the ratios between the sides. And then purple, we have 4 over 8. And when you have a similar triangle, these will all be equal. And of course, we know that 3 over 6 is equal to 1/2. Because 3 goes into 6 one time, or 2 times, sorry. 5 over 10 is equal to 1/2, and 4 over 8 is equal to 1/2. So these sides are proportional, okay, and that's what it looks like in numbers. Now, if two polygons are similar, I'm looking here now at scale factor, then the ratio of the lengths of the two corresponding sides is called the scale factor. So the scale factor in this is going to be equal to 2. because we multiplied everything by 2, okay? Sorry, the scale factor would be a half. There we go. So, because they're all equal to 1/2. Okay? So, let's continue. Here's an example. Okay, in the diagram, triangle RST is congruent to triangle XYZ. And we want to list the pairs of all congruent angles. So, we know that R is going to be congruent to X. Okay, and here we have R is congruent to X. We know S is going to be congruent to Y. And here we have, and there's that sign for congruence. Okay, and then we know T is congruent to Z. Okay, so again, that's half of the battle. Now we're going to check that the ratios of corresponding side lengths are equal. So here we have RS compared to XY. So RS is here compared to XY. Okay, we can tell that's 20 over 12 is equal to 5/3. Okay. Now, ST over S over YZ, so ST is here, YZ is here, and their ratio is 30 over 18 is also equal to 5/3. Okay, and finally, we have TR over ZX, and that's equal to 25 over 15, which is also equal to 5/3. So this ratio is 5/3, this ratio is 5/3, this ratio is 5/3. So these two triangles, or the sides of these triangles, are proportional because these are all the same. Okay. Now, because the ratios in part B are equal, okay, and the pairs of angles are congruent, then we know for sure that these two triangles are similar. And in fact, they look similar, so it's not that hard to imagine. Okay, let's do some problems. Okay, so this is really simple. So we're finding the ratio of the width to the length of the rectangle. Now here, they're choosing, okay, this vertical side is the width, and this side is the length. With rectangles, you could choose either one, and it would be totally fine. Okay, it doesn't really matter. So they're asking for the width to the length. So that means the width is over the length. The width has to be on top. The length is on the bottom. So the width is the 4 to 12, because 12 is the length. And we simplify. Don't forget to simplify. Okay, 4 over 12, and that means the ratio is 1 to 3. Okay, here again, we have our width, and we have our length. And because they're asking for width to the length, we put the width on top, which is 6. Put the length on the bottom is 10, and we simplify to 3 over 5. Okay, again, width, length. Okay. Now, this is where they get tricky, and this is very classic. Okay, you might be tempted to say, oh, the width is 1 and the length is 18. Okay, but you have a problem because your units are not the same. This is in feet and this is in inches. Okay? So your units have to be the same. So it's easiest to just put them in inches. So 1 foot is equal to 12 inches. And so now they're in the same unit. And we can proceed. So again, width to length is the same as width over length. So your width is 12, your length is 18. You simplify, and that's going to be equal to 2/3. Okay, so be careful of those units. Okay, that can be something really sneaky that you can find on a final. Okay, so here we're going to solve some proportions. So how do you solve a proportion? You cross multiply. Okay, and I think you all are probably pretty good at this point, at this point. So here, by solving the proportion, we need to find x. So we're going to cross multiply. Okay, 4 times 15. It's going to be equal to x times 5. There's our cross, or 5x. Okay, 4 times 15, 20 is 60, is equal to 5x. Divide both sides by 5, and x is equal to 12. And there we go, we got it right. Okay, here's 20. So 5 times y is equal to 20 times 8. 5y is equal to 8 and 16 is 160. Okay, y is equal to 160 over 5 is 32. And we got it. Okay, now these get a little bit trickier because they're making expressions. It's not just pure numbers. You're going to have variables in there that are actually connected with numbers. But you just do the same thing. So 12 times z plus 2. And I could do z plus 2 times 12. It's fine. If you wanted to, it's going to be equal to 4 times 27. Okay, so 4 times 27 is 108 is equal to, now you're going to have to distribute here. This is back to algebra. So 12z, 12 times z plus 12 times 2 is 24. And so you're going to subtract 24 from both sides, and you're going to come up with 84. Divide both sides by 12, and you get z is equal to 7. Okay, so there's some algebra in there. Okay, you had to distribute, you had to collect your like terms, and then you were able to determine what z is. Okay, I'm going to erase this part. If you needed to copy more, you could rewind the video easily. Okay, so number 22, 3 times x minus 6, don't forget parentheses, or you'll mess it up, is equal to 1 times x. So we distribute 3x minus 3 times 6 is 18 is equal to 1 times x. It's just x. Okay, so why don't we move the x onto the left side? So we're going to subtract x from both sides. This is going to be 2x minus 18 equals 0, because x minus x is 0. Now we're going to move our 18 over. So we're going to add 18 to both sides. Okay, I'm going to end up with 2x equals 18. Divide both sides by 2. X is equal to 9. Bingo. Okay. 3 times m plus 1 is equal to 2 times m plus 5. So now you're going to have to distribute on both sides. 3 to m, 3 to 1. So 3 times m is 3m. I have a plus in the middle. Plus 3 is equal to 2m. plus 2 times 5 is 10. Okay, so let's gather our like terms. So let's subtract 2m from both sides. Didn't mean to put that long line there. So 3m minus 2m is just m plus 3. 2m minus 2m is 0. So that goes away. 10. Subtract 3 from both sides. M is equal to 7. There we go. Finally. Okay, save the best for last. So we got 2 times 3k minus 4 is equal to 5 times k minus 1. We distribute. 2 times 3k is 6k. A minus sign in the middle. 2 times 4 is 8. 5 times k is 5k. Minus in the middle. 5 times 1 is 5. Okay, we're going to subtract like term, or I'm going to move the 5k over. So I'm going to subtract 5k from this side. I'm going to subtract it over here, and I end up with k. K minus 8 is equal to minus 5. Oops. Okay, now I'm going to add 8 to both sides, end up with k is equal to 3. And there we go. Okay? So hopefully that it becomes pretty much just rote for you for now. Okay. So here we have a nice triangle, and it is telling us that AC to AB is equal to 3 over 4. So let's take a look at what that means. So there's that word to again. So AC over AB, we'll put it into ratio form, which is what we're used to at this point, is equal to 3 over 4. Now let's look at our triangle. So here is AC. Okay, so that's equal to x. Okay, and here is AB, and that's equal to 12. So now we need to solve for x. Cross multiplying. 3 times 12 is equal to 4 times x. 3 times 12 is 36. Is equal to 4x. Divide both sides by 4. X is equal to 9. So let's plug it in and see if it works. 3 fourths is equal to 9 twelfths. Sure enough, 3 times 12 is 36. Also, another way we can look at it is 3 times 3 is 9, and 4 times 3 is 12. And 3 is the same on both the top and the bottom. So we know that this is true. So our x is equal to 9. Okay. Okay, we did that one. Sorry. Okay, here we've got AB to CB. The ratio is equal to 2 to 1. So AB is here. That's 16x. Okay, CB is equal to 24. Okay, so we're going to cross multiply. 2 times 24 is equal to 16x times 1. 2 times 24 is 48, equal to 16x. Divide both sides by 16. X is equal to 3. Okay, so let's plug it in. It's equal to 16 times 3 over 24 is equal to 48 over 24. And sure enough, that's equal to 2 to 1. Okay, because 48 is 2 times 24. Okay, pretty easy. Okay, we have ace, oops. We have AC over BC. The ratio is equal to 7 over 4. Okay, AC is equal to 21. It's messy. 21 over BC is equal to 2x plus 4. Not 5, 4. How can I say one thing and write another? Okay, so we're going to cross multiply. 7 times 2x plus 4 is equal to 4 times 21. So we distribute. 7 times 2x is 14x, plus in the middle. 7 times 4 is 28, is equal to 4 times 2 is 8. 8. That was scary. Okay, we had a little bit of a technical problem here, so I'm hoping the rest of that video works out okay. Okay, so I don't remember if we had finished this one yet, but I'm just going to go through it really quickly in case we didn't. So we have AC over BC is equal to 7 over 4. So here's my AC, here's my BC. Okay, is equal to 21 over 2x plus 4. Okay, so 7 times 2x plus 4 is equal to 4 times 21. No, I'm thinking we did this one. 14x plus 28 is equal to 48. No, 84. Sorry. 14x is equal to 14 minus 8 is 9. 56. X is equal to 4. Okay, so 2x plus 4, 2 times 4 is 8 plus 4 is 12. Okay, so 7 over 4 is equal to 21 over 12. And that looks good. Okay, so let's go on to the next one. Okay, so here you've got to be really careful to look at what it is that they're asking for. Okay, so, and I'll color code it. So we have AB. Okay, AB is right here. Okay, AB is 6. Okay. Over BC. BC is this little piece right here. Okay, and it looks like that is unknown. Okay, there's no number associated with that. Okay, let's look at AE. So AE is equal to 12. And ED is equal to 4. Now you can imagine how the problem would get messed up if you didn't, or you weren't careful about which sides were which here. So please be very careful on these. So we have 6 over BC is equal to 12 over 4, and we're being asked to find BC. So we're going to cross multiply. 6 times 4 is 24 is equal to 12 times BC. Divide both sides by 12. You're going to get 2 is equal to BC. Okay, and sure enough, there is BC. So what we were finding is right here, 2 over BC. Okay, it's not difficult as long as you keep the side straight. Okay, that's going to be the tricky part. Okay, let's look at another one. So here we're being asked to find BC. We're being asked to find BC, and here is BC. We don't know what that is yet. But they're telling us that AB is equal to 12. AE is equal to 18. And we need to know what ED is. Here's ED, but we don't know what ED is. But we do know what this whole length is. That's 33, and we know what the AE part is, so we can subtract and find out what ED is. So we're going to take the whole length, AD, we're going to subtract AE, and that's going to give us ED. So our whole length is 33. We're going to subtract AE, which is 18, and ED equals to 3 times is 5 is 15. So ED is equal to 15. So now we have our ratio and we can find BC. So we have 12 over BC is equal to 18 over 15. We cross multiply. I have all these written out so I don't make a mistake. Okay. So 12 times 15 is equal to 18 times BC. And I work that out. 12 times 15. 2 times 5 is 10, carry the 1, 2 times 2 is 3, and 15 is 180, is equal to 18 times BC. Okay, BC is going to be equal to 10. We divide both sides by 18, and sure enough, there's my 10. Okay, so on to the next one. So we're given FD. You notice it's that whole line. So FD is going to be equal to 9 plus 3 equals 12. Okay. Over FE. FE is just this part right there. And that's equal to 9. Okay, it's equal to CD, what's that big guy right there? CD, which is in 16, over BE, which is this guy right here. Okay, and that's the one we don't know because it says find BE. So we have 12 over 9 is equal to 16 over BE. Okay, and you know the drill by now. Cross multiply. 12 times BE is equal to 9 times 16. 12BE is equal to 144. Divide both sides by 12. BE is actually going to equal to 12. So BE is equal to 12. Again, you have to be very careful what you're looking at here. Okay? So, and color coding really helps. So on the final, you're welcome to bring different color pencils or markers and use them to work these problems. I highly recommend it, actually. Okay, this one is a little tricky. 14, yeah. So AB, given AB, okay. AB, we don't know. Over BC. BC is 5. Okay. Is equal to FE, which is 4. Over ED, which is 6. Okay. So now, they're asking us to find AC. Okay, AC is this whole length here. But the problem is we can't know AC unless we know AB. So we have to use our cross multiplication to find AB, and then we can find AC. So here we have our cross multiplication is AB over 5 is equal to 4 over 6. So 6 times AB is going to be equal to 4 times 5 is 20. AB is equal to 20 divided by 6. Divide both sides by 6, and we're going to simplify that to, what do we need to divide it by? Let's divide both sides by 2. We're going to get 10 over 3. I didn't mean both sides, I mean up and down. The top and the bottom, we divided them by 2. 20 divided by 2 is 10. 6 divided by 2 is 3. So AB is equal to, actually that's in green, 10 over 3. So how do we find AC? AC goes from here to here. So we've got to add them together. So AC is going to be equal to 10/3 plus 5 over 1. Okay, notice this is not a cross multiplication. This is an addition here. Okay, so we need to make the denominators the same. So we'll make them both 3. So we multiply 5 times 3, 1 times 3, plus 15 over 3. This is basic math. Okay, and that's equal to 25 over 3. And sure enough, that's our answer. Okay, so this was a two-stepper instead of just the one-stepper. Okay, so this is the end of the review for Chapter 7. If you can get through this pretty easily, then you're in good shape. If not, please ask questions and keep on studying.